Right.
Very small.
I missed all that. Like I missed all the button.
Oh.
Son of a gun.
Yeah.
So
What was going on?
this is like 0.012 inch. That's considered a large diameter tubing. You
Yeah.
can actually see the hole at the end of the tube.
Right. Yeah.
With the newer stuff, like some of this peak tubing, it's really, really, really small diameter, but you get higher pressure that way.
Yeah.
So the move has been from these older systems with the high diameter, moderate pressure to the newer systems, which are smaller diameter, ultra high pressure, and that the whole point is to shorten your run times, so you
Okay.
can run these in 5 minutes instead of an hour. And when
Yeah.
I started, everything was an hour.
Yeah.
Okay, so that's ready. This is optimizing. That lamp is warmed up, so it's going through its optimization to make sure it sees all the different wavelengths and finding the calibration peaks. With deuterium, there's a 656.1 nanometers, which is whenever you have deuterium light going through, shining and being detected by a spectrophotometer, 656.1 is the known peak for that
Okay.
deuterium lamp, and we use that as a calibration peak.
Okay.
So if it tells you it's 676, your calibration's way off.
Yeah.
So it'll run that internal diagnostic.
It'll
check.
automatically calibrate it.
No, it won't.
No, okay.
No, as long
It'll
as
just say there's an error.
yes, if it's within spec, it just keeps going. So right now it's finding the calibration peaks. If it doesn't like what it sees, it'll give you an error saying
Yeah.
your calibration's off. Then you can calibrate.
And I have these user manuals down there.
Yeah.
So.
To calibrate is shift 3,
Okay.
but you want to have the right solution in there to calibrate it.
Okay.
And there's different solutions that are used. Usually it's aluminum oxide.
Okay.
And this, I'm not going to take it out right now. I'll wait till it's done. But this here is a flow cell with a cuvette holder,
Yeah.
which you can actually put in a solution just like on a spectrophotometer. Jam it in there and scan it, just like a spec. So you can
Find that
you can use
maximum
that as a spec. Now you're not going to be able to export that data,
Yeah.
but you can get it on screen. It's very rough,
Yeah.
but it's good enough to let you know.
For us, like it might be better just to run it over UV, find that peak, and then.
Yeah, but here's what that looks like. Put your cuvette in there.
It's almost like a big one, like a
Yeah.
test tube.
Yeah.
You use a square.
Yeah, we have those glass cuvettes.
It's 1 centimeter by 1 centimeter.
Oh,
It's
that's
the standard
small.
size.
Yeah, it just kind of fits right in there.
You want a cap on it so you don't spill out the top. You carefully set that in there, and then you can. I think it's shift. There's the shift scans. I don't recall all the buttons anymore, but okay, so we're good there. That number right there is your absorbance value. That number right there is your wavelength that it's set to. So if I want to set a different wavelength, I can do that. I think I just go shift wavelength. Okay, that takes us to dual wave. Sorry, that was one line.
We can maybe about that.
Okay, since that box is highlighted,
Yeah.
see how it's darker? I should be able to just say 254, enter.
Okay. So you can use the arrows to go up and down to different boxes.
Yep.
Yeah.
Can't really see what this.
That is like a range. I would always keep it at 2.
Okay.
There really shouldn't be anything on here you have to mess with other than the wavelength.
The wavelength.
That's
Okay.
it. Yep. Simple. Shows that your light is on. Shows you what your wavelength is.
Yeah.
Nice and simple. Down here, it's a little more complicated. And there are some good guides in here you may want to familiarize yourself with. A quick start guide. This is the 2695 separations module. This is where the separation takes place. So you can, if you're kind of stuck, you can go through here, and
Yeah.
it's a good primer for how to do things.
Cool.
I'm gonna see how much I remember
Yeah.
and try to show you.
Yeah, this
some
could be a
things.
cool project for a kid next year.
Oh yeah. Okay, let's see. If we hit exit, so we're gonna call this the main screen. If we hit exit, nope. We hit. That takes me to a screen where all my parameters are. Right now, I don't have a method loaded, but I'll show you how to create a method and save one. There's my flow. Again, everything's by arrow. So there's my mils per minute. That shows you the system pressure, so that's not an editable box. And that's currently set in bar. If you want to set it in PSI, you can change that.
I like bar.
Okay. Here's your composition. Right now it's 100% A. If you want to make it 50A, 50B, you just type in 50. You'll see the boxes come up. It'll automatically make the next one 50. If you only want that to be 25, make that 25. It'll make the next one 25. So they always add up to 100.
To 100, yeah.
You make that one 10. It's going to make the next one 15. So they add up to 100.
Cool.
But let's just do 100. Sample temperature, that's this. So this carousel can be heated or chilled. Typically you chill just to keep your sample from degrading. You might put it at 10C, 15C. You don't want to go too crazy, make it too cold because it can freeze.
Okay.
But you just, if you want to set it at 15C.
So would you pre-chill it and then put it in there?
Depends what your samples are and how you're storing them. So for at work, many of their samples are stored in refrigeration.
Yeah.
And then they want to keep them in a refrigerated, the same temperature, because they're very temperature sensitive.
Yeah.
If you're working with some caffeine, like our tests are caffeine, we keep them in the cabinet, we don't refrigerate them, we don't mess with that.
Okay.
And so that might be, but you can see that the temperature's starting to drop. Column heater, that's this guy, goes from 30C up to 60C. It's not a big range, but some analyses will call for 30 or 40. One nice thing about setting that to say 30, that shows your current, is that then it's consistent. It doesn't change with every time the air conditioner comes on.
Yeah.
So that's the main reason to set.
And are you using these arrows or these arrows? What's the difference?
These ones.
Okay.
1, 2, 3, 4.
Okay.
These I think probably take you to the beginning or the end.
Okay.
These guys are valves. You'll never have to worry about that. Degasser, you want to run that on. And when I turn it on, you should hear the degasser pump starting to go. You want to use degasser. What degasser does is it takes a solution like this. It takes a solution like that that has dissolved gases in it, simply because we just did a mixture. We created some dissolved gases. If those gases come out of solution during your analysis, you're going to get bubbles. And they're going to show up as peaks.
Yeah.
And you don't want bubbles.
Is it basically just like an ultrasonicator?
No, it's not. It's a little chamber that has a semi-permeable membrane in it, and on the one side it has a vacuum pump that pumps down the vacuum, and on the other side your mobile phase comes through.
Okay.
And as it's coming through, that any dissolved gases will migrate through that semi-permeable membrane to pull them out of solution.
Cool.
Okay, that's about it. These are more valves. Again, you don't have to worry about them. Next page, there's nothing there to worry about, so we'll just go back to the first page. That's really the only screen. And to get there, we just hit menu.
Okay.
So if I hit exit, or let's see, if I hit menu, it takes me back to the main. If I hit menu, it takes me back to the status.
Yeah, I think this is the main screen we were working with.
Right.
Yeah.
Is there anything you can do to ruin this? In other words, like I can't put water in a GC. I should never do that. Is there anything here that I would
Yeah.
like? Don't ever do that.
You don't want to let it sit in water, 100% water, because then you'll get that growth. You don't want to pump it dry, because then you're going to get air throughout the pump system, and it's probably dry now, so
Yeah.
we may struggle here to get it pumping. These are pretty tough as far as that goes. I think this is probably your best model to have for somebody pumped it dry. Well, there's a couple things we can do to rehydrate it.
Okay.
So those would be the two main things. Don't pump it dry, and that's easy to do because it's pumping. You think you got enough. You go to lunch, you get distracted. You come back, it's like, oh, it's been 2 hours instead of 1, and I just pumped it dry. It's not the end of the world.
Yeah.
What'll happen is that'll be tough on your seals.
I see.
So your pistons, which are in here, go through seals.
Uh-huh.
That keeps that tight. So when it's pumping it, there's no leaks. But when it pulls back and it pulls the solvent down, there's an effective draw.
Yeah.
If you pump it dry and you keep pumping it while they're dry, they will get, they will crack and they'll have to be replaced. And then you won't get good pumpage. By leaving just water in the system, you'll have that growth that could grow in your flow cell, and then it's going to be hard to clean out.
I've seen Hazel rip one of these apart that summer I was there. So like if we buy replacement seals, follow that, watch a YouTube video, I'm pretty sure we could replace the seal like if we had to.
Yeah, it's we've been doing them ourselves for a long time. You want to take, what you do is you take these nuts off, and they're on there tight, but you unscrew them, this pulls out, you'll see your piston in there, you'll see the seals, and you put it back.
It's just basically little O-rings.
They're kind of like flat O-rings.
Yeah.
So are we waiting now for the system to?
No, they're just waiting on us.
Oh.
So I just wanted, before I started doing anything, I wanted to walk through the basics
Yeah, that was good.
of what we're looking at, and so that when I turn it on, you'll know what's going on. So the column has been heating up. It overshot the 30C, and it'll come back down to 30 because now it's turned off the heating elements. Tell me. Oh, did we set that? Yeah, we did. That doesn't seem to be chilling, but that's not a big deal for you. That's not going to affect anything that you do. You're not going to be running temperature-sensitive samples. And it's coming down, but it's slow. Yeah, you can kind of feel some cool air coming through. Carousel. Five different carousels. There's 5 different trays. You can put 24 in each one, so you get over 120 total samples. And you want to start with number 1 to, if you were to fill this, then you could go to number B. But I think you'll be running, 1 through 10 or something like that.
Does this? Are these little test tubes we put in there, or are they special?
No, little like GC vials.
I don't know what you said.
We have G.
Oh, like those little tiny ones. Yeah.
2 mil.
I got it.
These things here.
Yeah.
These actually might be the right size. No,
They're
those
too
are
big.
big.
It's small.
Very small.
Yeah, and they have like little symptoms.
Yep. And you have a crimper or screw cap.
Like 1 milliliter
But yeah,
or
they're
half a
tiny
milliliter.
versions.
Yeah, they're this big
Yeah.
and small enough to fit in.
So if you have any expired ones,
Yeah. There's a whole shelf of stuff. That's giveaway stuff there.
So does this automatically?
yeah, it
test
turns
it?
it,
It turns
needle,
itself.
sucks it out.
Yeah.
Yeah.
And we're not going to be able to do an injection because we don't have the syringe hooked up, but we can walk through everything and simulate that. It's not going to hurt anything. All right, so the first thing I'm going to do is turn the pump on, get it flowing. Set it to a milliliter per minute. And our waste is in the waste jug. Good. I think didn't bring his safety glasses. Do you have
Oh, yeah.
have an extra set? So trained to wear glasses all the time.
I have some kind of clear ones if you don't want to wear like.
That's
Yeah,
all right
that's
with
great.
me.
That's fine. Okay, so we're not getting any pressure, which is not surprising. I think we have this thing's been sitting for a while, so it's all dry. Wasn't pump dry, but it's dry. If we were, we would be seeing waste coming out here, waste coming out the UV here. We're not seeing that. So I'm sure the system is full of air. So I'm going to try direct function. I'm going to start with a wet prime and say okay. So what it's going to do is it's going to run a flow mill, 10 mils a minute for, let's say 2 minutes and see what happens.
So if you would run it dry, you do that wet prime.
That's the first thing I would try.
Yep.
It's going to go really fast, try to get that stuff through. Sometimes that works, sometimes it doesn't. Yeah, see our temps dropping there. Good.
Yeah, Tom said before they took them offline, they double checked that they all worked. So we knew it when they took it, at least everything was working with them.
Well, I knew we were either going to be donating them or using them for parts. And I wanted to make sure we either gave somebody something that worked or we had parts that were functional. I didn't want to have my guys taking out a pump that didn't work and try to fix something with it, and nothing worse than using bad parts.
Waiting for something to come out the other end.
Now, right now, if it was coming out anywhere, it would probably be this line. Yeah, I'm not seeing it. This is not surprising. Do you have a syringe?
How little?
Like a GC syringe?
No, something bigger than that. Something more like with a barrel like that size.
Yeah, over here.
Grab it. With like a Lorlock angle.
Here, maybe?
Oh yeah, I have.
Yeah, in that Boyle's Law thing.
Oh, actually, up here is the pressure box.
This has sand.
Yeah.
These
But
guys
we
here.
have to.
Yeah, but that's exactly what I need.
These don't absorb water.
Yeah, perfect. That's just right. Okay, well, we are getting some pressure, which is good. So we'll give that a minute. So now the flow path has changed and it's now
Oh,
pumping it.
I saw
See something come
something
through?
go through there.
I'm going to take the flow rate up a little bit, help it along.
Yeah, there's definitely some stuff coming.
Okay, all right, great. Yeah. That's why one thing I like about these is
You can see everything.
they're easy to bring back.
Okay.
Yeah. We have some that we struggle with, even when they're not pump dry, they haven't been sitting. The new Agilents, again, ultra high pressure, are really tough to bring them back once there's air in the system.
Oh.
Yeah.
You don't, you don't want to be the person that lets it run dry.
No. So good. I think we got flow. We have 40 bar with no column in. That's pretty respectable. What I was going to show you with this is what you can do is this little port here. See that knurled
Yeah.
knob? If I put this on here and open that up, I can pull
Suck the air out.
and pull it from there down through
Okay.
to help it go.
Okay.
So I was getting some there. So that's a good tool to keep.
Yeah, just leave it on the cart. We'll replace that.
I'll show you where to keep it, right in here. It's got a little storage spot. So it doesn't go missing. Alright, 39 bar. It's holding pretty steady, which is a good sign. That means our seals are probably good. Temperature's down to 14, that'll come back up. It's overshot, and it's coming back down. It's at 30.8. I'm going to show you a couple other functions under direct function. The first one is going to be this white. What goes through here? This is there's a seal wash on here. So what that does is it pulls solvent up through one of these lines. I think it's one of these bigger lines, one of these green ones.
Okay.
This one here. And it's going to pull the sample up. It's going to take it behind the pistons. And what that's used for is to bathe the back of the seals
Okay.
and the back of the pistons, especially if you're running a buffer. Because what happens with buffers is that piston goes forward, and then when it pulls back, it's pulling all that buffer, which is a salt solution, with it. And then when it gets back, it can flash dry. And now you have salt around that piston, and when it goes
Okay.
back through that seal, it's going to scratch the seal.
Okay.
And so what they do is they have these seal wash, and that goes behind the seals,
Okay.
and it cleans those pistons when they come back.
So it's always running, whether you set it or not.
No, you can
No.
turn it on or off.
Oh, okay.
Yep. So let's see. I go into direct functions. I can. Let's see. There's lots of things I want to show you here. I'll have to find out. Another one is needle wash. That's your green one.
Okay.
And all that does is if you're running a bunch of different samples, it washes the needle between each sample so you don't get carryover contamination. And there's a way to do that too. It'll all be outlined in the book.
So if you're going from low to high concentration, it probably doesn't matter.
Right.
But if you're going from high to low,
It wouldn't matter.
okay.
Yeah. Let's play around too. Okay, here's some more. Diagnostics. Prime seal wash.
Okay. So that was from the other main home screen.
Yeah,
This
I'm
is
not
just
really getting the screens very well, but at least we're
Yeah.
getting the conversation, which is
Yeah,
good.
this is a peristaltic pump, and that's pulling that solid from up there through one of the white lines down through, and then that will run during your analysis just to keep your seals. So when I've had enough of that, I just hit halt.
But you really only need to be doing that like during a buffer procedure.
Yeah, I don't think it really gains you a lot of systems don't have seal washes on them.
Okay.
Yeah, the older systems don't. Prime needle wash. Start. That's going to push that needle up. What that's doing is that's running from the green line through these lines right here. And there somewhere. You can't see the needle. It's actually, yeah, you can't see it.
So it only comes out when it needs to inject, or it stays in there all the time.
Yeah, you never see the needle.
So what's the thing that goes here?
The syringe. So the syringe,
I'll put the
a little glass one. All right. So when you inject a sample, this syringe pulls down. The needle, which you can't see, is
okay.
stuck
I was
into-
thinking that was the needle, but that's
No,
the syringe
that's
to.
the syringe. Yeah, your needle's in here somewhere.
Okay, so when the needle's in, that syringe pulls the vacuum to.
Yeah.
pull it
So
up.
you say you want to run sample number 1.
Yeah.
You say start. Here's the carousel. Sample number 1. Over underneath the needle, which is back in here.
Yeah.
It pierces that septum for that little vial, and then the syringe will pull down, pulling sample out of the vial,
Okay.
and then the needle comes out. The carousel moves out of the way. The needle goes back down and it ejects it into the flow path.
Okay.
And we can do that without even installing that, just so you can see that mechanism. So, okay. So then close the door. Close. Yeah, all these buttons you will need. Like compression check and adjusting seals and
I think we just need like a Saturday to come and mess around.
yeah.
I think I'd rather do this than build things out of trash. Although it sounds fun.
Okay, so we've seen the pump, how to adjust the pump, the flow rate, the composition, the column heater, the sample temperature, the degasser's on. Now we want to do an injection. So let's do a direct function. Inject samples. Okay. Now it might tell us there's a vial missing. Vial 1, injection per vial 1, run time 2, enter, inject volume 2, enter. So it's going to tell you I'm running a default method, vial 1, injection 1 of 1. It's the final injection. It's selecting the vial, so it's pulling the carousel around. So vial number 1 is underneath the needle.
Does it have a little reader that it reads the numbers? So like you don't have to put it like in a certain orientation in there.
No.
Okay.
You don't.
So it's not like you can mess up the spin of it. You just stick it in there.
Right. See, it's got this little magnet,
Okay.
and that reads that.
Okay.
That's how it
Yeah,
moves.
that's so smart.
I know. It's simple too, and it works. It's effective.
If we do this, I'm sorry to interrupt, but if we do this and it thinks it's pulling something up, isn't it pulling up air?
It would be
And that's not good for the system.
a
right?
little bit air like that's no problem.
Okay.
No, I'm talking about pumping it through the
Okay.
system dry. That's injecting 2 microliters of air is.
It's not like
But it was smart enough to know there's no vial there.
Okay.
So it said missing vial. What's up? Sample suspended. So we're
Okay.
going to abort the inject, and we really can't do the sample injection, even faking it without a little vial.
Yeah.
You don't have any of those little glass vials, right?
I
feel
don't.
like
know.
I'll be right back.
Okay.
I don't think this is
But to see if that thing works, I could put a cuvette
Yeah.
in there, right?
Well, yeah.
Just to see
and-
if we get a millivolt signal.
Right. You should be able to see it. It's already gone up. So if I hit balance on this,
Let me get the computer running so
Yeah.
it's collecting data.
and then we'll
So that if you see any changes.
Exactly. Oops.
that's gonna be the tricky part. If this it has a grounding wire, if I plug this onto the metal body, that would essentially ground it.
I
right?
think there might be a port on the back that you could do that. Sometimes there's like a screw.
Oh yeah, right there.
Yeah, there you go. Perfect.
Okay, so we got potential millivoltage. We're gonna do time-based minutes. We won't need 30 minutes, but that way we don't have to restart it. Samples per minute, 60 samples a minute. Go 30 minutes. So right now it's sensing 2.20 millivolts.
Okay. And is it graphing that?
Yes. Right there.
Okay. So let's let that go to establish a baseline.
Yeah.
And it will, there's something on here called chart mark,
Okay.
which would give us like a start signal.
Okay, right,
We'll
yeah.
see if that comes through.
Yeah.
That may or may not come through because that might be a different set of
Okay.
outputs. Yeah. So if it
And
doesn't,
we never really cared if this millivoltage on this thing was at 0. We just wanted to know what the
Right.
baseline was, and then
Right.
if we saw a peak.
Yeah.
There would be a way that we could zero it if we wanted to.
Mhm.
I don't think I can do it while it's running, but I think had I done it beforehand, I could calibrate it and zero it.
Can you blow that up at all to see if there's any variation? Okay.
You're talking like
That's
0.03 volts?
Yeah.
0.03 millivolts.
And up here it's going from 1.1205 to 0.1204. It's very, very
Pretty
small.
constant. Okay.
These would be millivolts.
Makes sense based on what we plugged in already.
Probably millivolts, yeah.
Okay. And this is just amplifying those millivolts.
Well, you could try that too. See what happens if you turn the knob.
So right now it's at plus or minus 20 millivolts. I could go to plus or
So that's more of a range, not a.
well, it's an amplifier. So if I turn this, like it would amplify it by different.
Well, tell you what. Let's not.
Yeah.
That might. Let's see what happens here. I do chart mark.
Oh yeah.
I didn't touch it yet.
Oh.
So.
Oh yeah.
Okay, so it's
Definitely.
talking.
So this was our baseline before. I thought something was happening here, but that could have just been from me touching this. And
Is this when you turn that knob?
that's that chart mark. This is when I was I didn't turn the knob, but I was kind of touching the equipment. But every time he hits chart mark, that's basically saying when he's starting the instrument. So that's kind of your time 0.
Starts. So
Well, that's
that means
cool.
it's talking.
Yeah,
Okay.
that's great.
So let me see if I hit. Well, how do I auto zero? It should. My number's going to get down, so your graph should drop down.
Oh yeah.
All right.
Look at this. This is great. All for $89.
I think you're onto something there.
And now they're talking about making a Bluetooth version of this. So then we wouldn't have to deal with all this. Like this thing would be Bluetooth going right to your. At first they were like, there's not a market for it. But I'm like, just you wait and see. With all these in the market going down, like, they're gonna,
Man, I can just. I swear we have some of those files somewhere. I don't know why did we have those? I feel like we got some and we were thinking, what is these?
What I was saying was, I have a little Tylenol standard in there that I use for the UV vis. We could just fill a little cuvette, put it in this detector, it's not going to run through the instrument, but it'll at least say, all we really care about is that the detector communicates. Once this is all hooked up and we have a column, then we can figure out that. But this seems like it's communicating. So.
Yeah, it does. All right. Well, it's probably about as far as we can go.
Right. Yeah.
With what we've got.
That's awesome.
But I think
How do you shut down after a run? So you run all your sample.
Good point. So we're done. We're going to turn off the flow.
So you just like manually set that back to
All
0.
you have to do is hit stop flow.
Oh, stop flow. Okay.
Yeah. Or you can put that back to 0.
Okay.
Either way.
Stop flow.
So now that's just to.
And if we had a sample in here, would you have to do like a purge or
I
like
would
a clean your column?
Yes. So if you were running some type of analysis, you'd want to make sure that when you turn this off, you've got the system flushed with your storage solution, which is going to be
50/50 methanol water.
and isopropyl.
Oh, that works too. Okay.
Yep.
And how do you know if it's thoroughly flushed? Just because you're.
Yeah, like how many milliliters would you flush?
I would probably do each channel, so set it 25, 25, and add 5 mils a minute for 5 minutes.
You got that on
So,
video? 5 milliliters.
25 milliliters, that should be more than sufficient for you. And that'll flush the 4 lines out, that'll flush up through here, clean out your cell.
Okay.
Yeah.
Cool.
How much do you charge by hour to be on emergency standby?
Well, you can call me and if I'm available, I'll answer your question, or text me and I'll get back to you as soon as I can.
Cool.
So after that, you've done your flush, then you just turn this off and turn this off.
Turn it off.
Yeah.
Sweet. Easy peasy.
It is pretty basic and easy.
That's awesome.
It's been a workhorse.
I'm saving
for
this
us.
graph and I'm sending it to Vernier tomorrow.
Yeah.
It proves that it works. So.
Yeah.
So we need some files.
Yeah, I'll put that on my list.
And I would get the screw cap because then you
Yeah,
don't need the
you don't need the
tool.
crimper. That's why I got those.
Yeah.
Because I had a kid mixing horse manure in bell jars, and then he had to open them to like get the gas sample out. I'm like, never again.
Yeah.
You're sticking your poop in those things, and you're getting. That was so bad.
Yeah. We need a knurled nut.
Syringe frit, syringe nut,
Yeah.
some sort of aspirin column, a restrictor. If we can't get the column, you said the restrictor would probably be good enough for us.
If you text me those, I'll see what I can round up.
Screw cap files. Yeah, and if you give them to John Wenger, he sees me every week. So,
Oh, okay, right.
yeah, he's always like bringing stuff in his trunk and doing like, "Here, bomber."
Yeah. Well, we hate to see stuff get thrown away.
Yeah,
And
we
when,
love it.
When we trade them in, you know what they do? They nip the board so you can't use it. And they say, it's up to you to get rid of it. So we can't use what we trade in because they don't want us, they want you guys to buy one. They don't want us giving them to you. We didn't
Yeah.
trade this one in, so it was still intact.
Yeah,
And to trade something in, we have to buy something. And we're not buying right now.
you're not buying from them. Yeah.
So,
All right.
yeah, we've got, well, you saw the wall.
Yeah. Yeah.
Plus have another 20 beyond that. That's,
I mean, could
All right.
they
So
really
this is
just-
still running because this is on. I can turn that off.
yep.
Wait, is this how old is this instrument? What is that?
This was LC 113. So, well, the model itself goes back. I started in metrology back around 2003, and they already had probably 10 of these. So this goes back. The model goes back before 2000. This particular instrument was purchased well after that, probably in the last 15 years. Let's see if there's any kind of
It doesn't really matter. I was just
serious.
curious.
Well, I'm curious too.
Maybe it says in.
It can't be older than these things.
Yeah.
2007
Okay.
is how old that is.
Let's see.
Waters. Yeah. And the sad part is we have to get rid of all these simply because of software.
Yeah. It doesn't,
And
yeah.
and this happened before when we had GCs that were variants, and they switched to Atlas software, and they couldn't use them anymore, and because they didn't talk. was too
Yeah.
old. So I gave one to Millersville, and then that's how I ended up working at Millersville.
Oh, is that right?
Well, I had taught there, and then I kept in touch with people, and then the lab donated this GC, and they called me and said, "Hey, we got this GC. Could you help set it up?" Sure.
And you said that button on there was strip start? Like you press a strip start button on there?
Oh, up here,
Yeah.
it was chart mark.
Oh, chart mark. Okay.
That sounds a little better. Chart mark.
Yeah, so they're like, "Hey, can you come in and work on RIC? Can you come in and work on it?" So I started doing that, and back around 2005.
So do you work your full-time job and then do that?
I don't do that anymore,
Oh,
but I used to. Yeah,
wow.
yeah. And it was once in a while, and
Yeah.
it wasn't all the time. But I did it at York College, Millersville, and there's this little startup lab in York that I was doing some work for.
Wow.
They just had a couple LCs and had no idea what they were doing. So,
That's like Millersville. They got this brand new scanning electron microscope. The professor
Oh, yeah,
left.
Yeah.
It was just sitting there for like 2 years. Because they sent all of us local high school people, hey, we're getting this, and it was part of the grant. High school kids can use it.
oh wow.
And then for 2 years, I tried to get in contact with them, nothing. Well, it's because the guy left. So they got a company rep who basically set these up for his job. He was semi-retired.
Mm.
And they said, do you want to work for Millersville? So he goes in, whatever hours they say, we have a 4-hour sample we need you to run. And he basically sets it up for
Wow.
him.
Do you remember who the professor was that left?
I don't. But this guy worked for the actual SCM company. And
Who was probably in biology.
yes, because I was thinking it would be more chemistry, but
Yeah.
no, all these bio people are
Yeah,
using
that's
it.
right.
Yeah.
I wouldn't know who that was.
And what did we do to get that peak?
That was the
That was the chart mark.
Chart
Yeah.
So what were these other 2 peaks for?
I
Well,
think-
when I hit 0,
That gave us this.
that
zero.
dropped.
What? That was the chart mark. I wonder what those 2 were.
Those 2 were chart marks.
Yeah.
Oh, they
he
were
did.
chart marks.
And then here's where I hit
0.
0, and this is where you turned it off.
Oh, okay. Turned off. Okay. Cool. Yeah, this is great.
So what do you guys do over at Millport?
Well, we work with the Lancaster Conservation District, and we just do some basic stream sampling.
Mm-hmm.
So we do a little bit of chemistry and a little bit of microbiology. I mean, they'll take macros and
Macroinvertebrates.
yeah.
So it's a combination biochem project or
A little
field
bit.
trip.
Yeah. Mm-hmm. I mean, we
Okay.
test nitrates, pH, dissolved oxygen, turbidity, flow rate, and then Matt Coffroth will take kids and scrounge for macros, and then he takes all the data really and collates it. And we've been doing this for, oh my
Long
gosh,
time.
20
They said they have
plus
so much
years.
data.
Yeah, I don't know how good it is. But
Well, it's not just you guys doing it.
yeah, that's good.
F&M has done it. There's been other groups they were saying at the meeting tonight that have been collecting this data. They have tons of data.
Well, I think F&M has a station out there.
Yeah, they have
that's
a constant monitoring system.
in the water.
In the water.
In the
Yeah.
water.
Okay. They also have a seismometer there.
Really?
Yeah, so I'm just finding this stuff out. So we're
Dan, are you
looking
okay
at-
if I just leave this thing up here?
Well,
Or do you need it tomorrow?
Yeah, well, I just need one for tomorrow, and I'll just get one from Beth. It's okay.
No, there you go. I'm just gonna leave this hooked up here because we're gonna rip down the GECs anyways.
I wonder if I have I'm gonna turn this off. I wonder if we have a bungee in my room.